Okay, we're going to look at 3 exam questions on sector area and arc length. So the diagram shows sector OAB. AOB is 50 degrees. Sector OAB has area 20 pi. Calculate the perimeter of OAB. Right, so we're told the area. What's our missing information here? We don't have the radius. I'm going to put an X there. Because we can't find the perimeter, we can't find the arc length until we have the radius. So theta over 360 times pi r squared is the formula for sector area. So we know 50 over 360. I've called my r x here. Now here, you can actually divide both sides by pi, which just gets rid of the pi. So divide by pi, divide by pi. Just put what I've done here and we're working out, which gives us 50 over 360 times x squared equals 20. I'm going to times both sides by 360. Oh, I've just realised I'm not actually finished off this question. So 10.5 is the arc length. The question asks for the perimeter of sector OAB. So it's 10.5, add both your radii, add 12, which is 34.5 centimetres to 3 significant figures, which gives us 50 times x squared is equal to 7,200. I'm going to divide both sides by 50. £144. Square root both sides. X is 12. The radius is 12. Now I can find the perimeter of OAB. The perimeter of OAB, distance around the outside. That distance is 12 centimetres here. So we have also 12 centimetres here. So I just need the arc length, which is theta over 360 times 2 pi r. So theta over 360 times 2 times pi times 12 10.5 to 3 significant figures. The diagram shows an equilateral triangle with sides of length 5. D is the midpoint of AC. E is the midpoint of CB. So that length there is 2.5, so is that one. CDE is a sector of a circle centre C. Calculate the area of the shaded region. Right, so you might be thinking, where on earth do I start with this? So let's just look at our information again. We're told it's an equilateral triangle. Why are we told that? Think about your properties of an equilateral triangle. All the angles are 60 degrees. So now for our sector, can you see, we can now work out sector area because we've got an angle and the radius. So sector area is theta over 360 times pi r squared. So 60 over 360 times pi times 2.5 squared, which is 3.27. Make sure we write down those small decimal places because we don't want to lose accuracy in the answer. We want the answer to 3 significant figures. So if I take through 3 decimal places, that should be enough. Okay, what about, so we've got the area of the sector. Well, we need the area of this triangle, don't we? Because the area of the shaded region is the triangle minus the sector area. Area of a triangle, half AB sine C. Or, well, half base times height is the one you're used to using. But just remember from higher level trig, we've got half AB sine C. So we've got big C is the angle, which is what we want. Little c, well, A is opposite A, B is opposite B. So half times 5 times 5 times sine 60. 10.825. So the shaded region is 10.825 minus 3.272. Or you can use the whole answer on your calculator for the 10.825 because you've got that saved. Again, you just don't want to lose accuracy, which is 7.55 to three significant figures. Okay, have a go at these problem solving questions. So for the first one, we're given the area, we have a missing radius. So we know theta as well. 115 over 360 times pi times x squared equals 20. So I'm going to times by 360 first, which gives us 115 pi times x squared is equal to 7,200. I'm going to divide both sides by 115 pi now, which gives me x squared is equal to 19.9. So you might have done that in a slightly different way to me. And then I'm going to square root both sides, which reverses the square, which gives me x's 4.5 to one decimal place, or three significant figures, 4.46. Okay, part B. Times both sides by 360. Divide both sides by 26 pi. And then square root the answer. I'm going to just put this one a bit differently. Which gives us x is square root of 35,280 over 26 pi, 20.7. No, 20.8 to three significant figures. I'm just going to put these next two on a fresh page. This time we have a missing theta. So for part A, theta over 360 times pi times 5 squared, 17.45, times both sides by 360, gives us theta times 5 squared is 25, so 25 pi. Divide both sides by 25 pi. theta is 80.0 degrees. Times both sides by 360. $22,320. Divide both sides by 8.5 square pi. Gives us theta is 98.3 degrees.